Hello my ICT needers, welcome to this video. Are you passionate about machine learning and AI and you don't know how to start because you are not a computer scientist? Is your PhD or your master defense log because you are not able to analyze your data set using machine learning methods? Or do you want to start with machine learning programming and you are afraid by coding? This video is yours. In this video, we want to show you how you can use machine learning method to predict schizophrenia from a data set generated from raw EEG. So it is a supervised machine learning because in our data set we have an outcome column that contains both the data of health control person and the data of schizophrenia person. Before all, we want to precise that we use Anaconda Navigator principally or mainly Jupyter Notebook, and the supervised machine learning used here is classification because there is many kind of machine learning or supervised machine learning. We can have classification, regression, clustering, and many others. So I want to add the fact that the pipeline of a machine learning classification include data preparation, data exploration, data cleaning, feature engineering, and model selection, amongst others. So we are going to start with the analyzing step by steps. As we said, we use Anaconda Navigator. Let us launch it. Why Anaconda Navigator is launching, I want to show you, to present you our data set. So the data set that we want to use in this video is this data set. Let us open it. Our data set is a CSV file, and this data set include some input as name, EEG. EEG is the name of the whole file. You can see H is healthy, and S is schizophrenia, as you can see here. And we compute some inputs as degree, strength, density, channel, frequency band. Frequency band include delta, beta, alpha, gamma, frequency band of EEG, and the outcome column is called group. 0 is for healthy control, and S is schizophrenia and has 1 as a value, as you can see here. So our data set has 2,661 rows. Exactly 2660 row because there is a title row. So Anaconda Navigator is already launched. For a Python code, we can use Jupyter Lab, Jupyter Notebook, or Spyder as IDE. For this video, we will use Jupyter Notebook, and in the next video, we will show you the difference between that three IDE. Let us launch Jupyter Notebook. Jupyter Notebook. Let us launch it. Okay, it is okay now. Before continue, I want to precise that this video is inspired by the work of the work published in this website. The title of the work is Machine Learning Workflow on Diabetes Data. So, when your Jupyter Notebook is launched, you can have a response tree like that, and you can choose your workspace. In your workspace, you can create a new file, or if you already have your file as me or like me, you just have to open it. In this file, we want to explore the different steps, of machine learning pipeline. So we begin with data preparation. Data preparation is already done because when we have our EEG raw file, we pre-analyze all that EEG, and that analyze produce this file. The data preparation step include data collection, and as you can see, that step is already done and produce this file called Schizo CSV. So after the importation of some libraries, we have to read our data set. After we read our data set, we can go to the next step. The next step is called data exploration. Data exploration is the step that allows us to explore our data set. So in this step, we can display all the columns of our data set with the function columns. After that, we can display the height. So the five first rows of our data set, as you can see. After that, we can display the dimension of our data set. You can see the number that is the same here. Okay. Here there is +1 because there is a row for title. After that, we can group our data to see if our data is balanced. Is the group 1 row equal to the group 2? We can see that the data of 2 groups are equals. After, we can do some plots to see the value of each input in function of each outcome. So for outcome 0, healthy control, you can see that for the value of degree equal to 14, there is something like, I don't know the value or the number of data that has 14 as a value. You can see after 0, I don't know, it is we can say 20. Here we can see that 200 rows has a value equal to 16, and you can observe the value of all inputs for the first group. It is the same for the second group. Always for data exploration, we can find the correlation between the data, the columns of our data. This step can allow us to verify the integrity of our data. For example, in this step, you can be able to know or to confirm that 2 inputs are correlate or not. So if you have 2 inputs and that 2 inputs are not supposed to have a correlation, and in this step you notice the correlation between that 2 columns, you can know that your data set is not there is not integrity in your data set. So that step is very important. You can see here that the 2 first column EEG and unnamed are dropped before checking the correlation between data, because that 2 columns didn't have that 2 columns didn't have the number as value. So let us continue. After this step, after the data exploration, we can go to data cleaning. Data cleaning is to check if in our data set there are null value or there are some value that are not the number. If there is such value, we can decide to ignore or drop it and before continue our data analysis. So in our data set, there is not null value and nor no, not a number value. So this is the difference between the variable schizo new. In schizo new, we drop the two first column, and in the schizo we have our complete data set, as you can see. After the data cleaning step, we can go to that model selection step. Model selection is to define many classification models and check what is the good or the best model for our data set. So we decide to import the K nearest neighbor classifier, the SVM classifier, logistic regression, decision tree, Gaussian, random forest, and gradient boost classifier. You can add many other models. So we add that different model in a table, and we do some importation and split our data in train and test set. In this example, in this video, we decided to have our test size of 0.3. 0.3 is means that we have 30% of train set and 70% of train set. After that, we can have the different accuracies in function of each classifier. As you can see here, we choose our fault of 10, and launch and restart our classification model, and we can see that the accuracies are improved. After that, we can plot, and when you plot, we can clearly see that the random forest classifier is the better classifier for our data set, followed by decision tree classifier. So if you want us to continue the analysis, you can just write in the comment, and we will help you to do. We will show you the process. Thank you for watching this video. If you have questions, you just have to write it in the comments, and we will please to show you the answer by a simple process. So just write, and we will save you, because our mission is to make ICT close to you. Bye.